Let's sketch out the Lewis structure for O2, commonly known as oxygen. To accurately depict the Lewis structure of O2, follow these steps. Begin with a rough sketch. Illustrate the chemical bonds between the atoms. Recognize and mark any lone pairs present on the atoms. Ensure each atom has a complete octet. Conclude by calculating formal charges, aiming for a stable Lewis structure with the least formal charges possible. Before sketching the rough diagram, we begin by calculating the total number of valence electrons and then proceed to determine the central atom. The total valence electrons in O2 are determined by summing the valence electrons of each atom. Both oxygen atoms, members of group 16, contribute 6 valence electrons. With 2 oxygen atoms in O2, the total valence electrons calculation is 6 for 1 oxygen multiplied by 2, resulting in a total of 12 valence electrons for O2. For O2, either of the 2 oxygen atoms can be chosen as the central atom. Opting for the right oxygen as the central atom, the preliminary sketch of O2 involves positioning the 2 oxygen atoms side by side in a straight line. 2 electrons represent a single chemical bond. Therefore, we will position 2 electrons between the 2 oxygen atoms to indicate a chemical bond between them. In this way, out of the total 12 valence electrons, 2 are used, leaving us with only 10 electrons. Lone pairs consist of electron pairs not used in chemical bonding, and remember that each pair comprises 2 electrons. With 10 remaining electrons, we can make 5 electron pairs and mark them on the structure as lone pairs. Next, it's important to note that oxygen is a period 2 element and cannot keep more than 8 electrons in its valence shell. Also, remember to always start marking lone pairs first on the outside atoms and then on the central atom. In O2, the left oxygen is the outside atom and will get 3 lone pairs, while the central atom, the right oxygen, will only receive 2 lone pairs as we have only 5 lone pairs to mark on the structure. The octet is complete on the outside atom, left oxygen, but not on the central atom, right oxygen. So let's now concentrate on completing the octet for the central atom, the right oxygen. Once again, keep in mind that oxygen is a period 2 element and cannot hold more than 8 electrons in its valence shell. The right oxygen already possesses 6 valence electrons and requires 2 more to complete its octet. Therefore, we will convert 1 lone pair from the left oxygen atom and transfer it to the right oxygen atom to form a chemical bond. Now it is evident that both oxygen atoms form an octet. Thus, the octet rule is satisfied, and now we can proceed to check the formal charge to determine the stability of the structure. This is the formula we can use to calculate formal charges for the O2 Lewis structure. Formal charge equals valence electrons minus non-bonding electrons minus half times bonding electrons. Input the relevant data and allocate the values to calculate the formal charges for each corresponding atom. For each oxygen atom, valence electrons are 6, non-bonding electrons are 4, and bonding electrons are also 4. So the formal charge will be equal to 6 minus 4 minus half times 4, which equals to 0. The formal charges of both oxygen atoms are 0. Therefore, this structure is the preferable stable Lewis structure of O2. To represent a pair of bonding valence electrons, we can simply draw 1 horizontal line. Since there are 2 pairs of electrons between the 2 oxygen atoms, draw 2 horizontal lines between them, indicating that there is a double bond between the 2 oxygen atoms in the O2 Lewis structure. That's the Lewis structure of O2. If this breakdown helped, press the like button, share the video, and subscribe for more chemistry knowledge.